Let's look at how to name alkanes using a systematic approach, and then also look at how we can use those names to figure out whether we have isomers or identical molecules. So systematic names are really useful because we can determine the structure from the name. Even if it's complicated like the one shown here, we can look at the structure and we can figure out the name, or we can look at the name and figure out the structure. And indeed, there should be just one for each, right? So one name for each structure, one structure for each name. These are really different than brand names or generic names, which don't really tell us anything about the structure and are used more for marketing or are named after the person who developed them, or the person who developed them was allowed to name them. So with that systematic naming, which is what we're going to focus on, the names are set up so that you have the parent chain name, and it has a suffix which tells you the type of compound, in other words, the functional group that's in that molecule. And then you'll also have a prefix, and sometimes lots of prefixes that might have additional functional groups, and also tell you the location and types of branches or substituents, as we usually call them. So the first step in naming is to name the parent chain. And when you do that, you look for the longest continuous chain. And sometimes this is hard because the tendency is to want to just choose the chain from left to right, because that's how we read. But you can draw molecules in any which way. They don't care about that left to right thing that we do. So you might find parent chains wrapped around like they are here, or you'll just have to look and just find the longest chain of carbons that are in the molecule. And then actually, if I look at the previous one here, I need to count the number of carbons in my continuous chain. So it's 1, 2, 3, 4, 5, 6, 7. And so the name of that parent chain is heptane, right there. There's 7 carbons. And this ending A-N-E, that actually tells us that we have an alkane. In other words, just carbon-hydrogen single bonds in the molecule. So the second step is to assign the prefix name and locator number. And so this is really where we're looking at the substituent, which is over here. We only have one substituent, or one branch to the parent chain, and it is 2 carbons. And so a 2-carbon chain is called ethyl. So E right here, that's kind of hard. Now, instead of putting A and E, I actually put YL. I take off the A and E, which indicates an alkane parent chain, and I put on YL to tell me that this is a substituent, something that's stuck onto my parent chain. So this would be ethyl heptane. Horrible job. I'm horrible at this. Writing on with these pens. Okay, so ethyl heptane, and the last thing that I need to do is say where the ethyl heptane, or where the ethyl group is located. It could be located at any carbon, well, almost any carbon. If it was located here, for instance, it would actually extend the chain, as would the parent chain, and so would at the end. But in any case, I do need to indicate where the ethyl group is. And so I start numbering. I number my carbons starting at the beginning, or at one end of the parent chain. And here I see that my ethyl group is at the 4th carbon. Now, in some cases, you have to decide which way to name. Like you either have to start up here or down here, and then you end up with different numbering in those cases. And when that happens, you want to choose your number so that you get the lowest number possible. So this way, it doesn't matter. I get 4 whether I start from the upper side or the downside here. But when it's different, just choose the numbering system that gives you the lowest number possible. And so let's look at an example of that. Here we have 2 substituents on the same molecule. So let's look at, there's the parent chain. There's a couple other ways I could have drawn that, but that is the longest continuous chain. Same thing down here, I could have drawn the parent chain going up. I'll get the same result either way. So, write down 1, 2, 3, 4, 5. This is a pentane. So pentane. Okay, down here, this is 1, 2, 3, 4, 5, so I'm not going to bother rewriting it. Also pentane. And there are 2 substituents, 2 methyl groups coming off, 2 branch points. There's a methyl group there, a methyl group there, and there's actually one down here and one up here too. And so if I started numbering from the top, 1, 2, 3, 4, my methyl groups would be on carbons 3 and 4. But if I start numbering from this side, the right side, now my methyl groups are on carbon 2 and 3. And I'm going to do the same thing down below. I can see that if I start from the right side, I get lower numbers than starting from the left. And so it looks like in both of these cases, my 2 methyl groups are at the 2nd and the 3rd carbon. And so I write 2, 3, that should just be all one thing. There shouldn't be any spaces there. And then a dash. I'm not going to have quite enough room here. And then I write di, meaning I have 2 methyl groups, and I really don't have enough room. So I should put a methyl in there. I'm just going to give myself a little more room here. Write a caret there. All right, so the name is 2,3-dimethylpentane, and these are actually the same molecule. It's just they're in different, we call it conformations, and what that means is that there's been rotation about this bond over here, actually, and possibly, and also the molecules kind of shifted over or oriented over a little bit. So you kind of have to rotate it counterclockwise a few degrees and then also rotate around this bond, and you'll get this molecule, this orientation of the molecule. And you can see since they have the same name, they're actually the same molecule. So they're not isomers, they are identical molecules. They're just in these things that we call different conformations, meaning there's been rotation about a single bond. All right, so as far as other things that you'll want to, besides, you're going to need to memorize the names of the alkanes and those parent chain names, at least carbons 1 through 10, if not more. You'll also want to be familiar with or have in your mind these branched substituents. And so these are used as kind of a shorthand way of drawing substituent groups sometimes. So you'll sometimes see these, so you should kind of have an idea of what they are.